So, thank you. Welcome to my talk. What the world would look like if plugin instances could simply talk to each other. I think I might have won the prize for the longest talk title at the conference. I'm not sure. Anyway, so I'm Janos. I'm working at Sonable. We are doing plugins, an Austrian-based company belonging to the Audiotonics group. And we already had a talk from my colleague Peter on the topic of inter-plugin communication. So you see, this is something we as a company seem to care a lot about. But yeah, I will focus more on in-depth topic and raise some issues we had with this topic. And yes, so how did it all start? I think this meme from a Sonable Slack channel started the whole thing. So we were discussing problems we had with our inter-plugin communication, and someone just dropped in this, so what the world would look like if plugins could simply talk to each other. I think we're not quite there yet, but maybe after this talk. So what's the agenda? When we talk about inter-plugin communication, what am I even talking about? So I will show you an example of one of our products so that you might get an idea of what I'm talking about from an application point of view. I want to show you how we approach some of the aspects technically until now, and then we'll go into how we could do even better if we had some kind of host support for what we are doing. And hopefully we will have some room for discussion. So, what is inter-plugin communication or inter-plugin instance communication? So why do we even want plugin instances to communicate? They could just live in their own channel strip and everything will be fine. Was like this forever. And I think this can be best illustrated with a quick demo of our SmartEQ4. I just have a Pro Tools session here up. So this is a mix window. You see I've just inserted SmartEQ4 to every track. Let me just open up this instance. At first though, there's something popping up. This will be shown later to you. So this is just a very simple equalizer at the first glance, nothing too fancy. You can add bands, can declare them as dynamic bands and stuff like this. Probably stuff a lot of equalizers out there have today. If we look closely, we see this button, which is the Learn button. If I click it, it tells me it's waiting for audio to analyze. And if I now hit playback, you see this bar filling up. And what's happening, it will collect audio data in the background, listen to the signal, and then just hand it over to an AI that will derive this crazy filter curve, which is at the moment universal. And if I look right, I'm on a kick channel now. So I can just pick this kick profile and it will change. So you see we have kind of an intelligent equalizer over here. No inter-plugin communication so far. So now there's this button Add to Group, and this is where plugins start to communicate. If I hit this, I can either decide to join an existing group or create a new one. So I'm a drum channel now, so just pick drums, and here we are. We ended up in a drum group. And what is interesting now, you can see other instances here. You can see the analyzers and stuff like this. And we see they all have this kind of crazy smart responses. And I can hit Learn All. And this will suddenly trigger the learn function in all the instances. And all plugins will collect audio data and derive their own smart response from this. But not only a smart response local to this plugin, you can set this impact and you see them change in every instance. So we collected data from all the plugins, did a computation on the whole set of data we collected, and then do something fancy with it. And I can even say, I have layers here. So I can put my hi-hats back from the front to the middle of the mix. And this will recompute the curves. And yeah, so this tool is able to make smart decisions for your mix based on context information gathered from other instances. And you can even do something cool, which is remote controlling other instances. So you see, if I click stereo room here, I get the editor for the stereo room instance here. And now if I just open up this instance, which should be stereo room, and I add a band here, you see these instances being completely mirrored. So this is a rough rundown of what we did for SmartEQ4 and what we mean when we talk about inter-plugin communication. So the possibility to control plugins from each other, to exchange some kind of data, to detect them, and to group instances into logical groups. All right. Let me just quickly get the right slide. SmartEQ4 is not the first plugin we built that makes use of some kind of inter-plugin communication. There was SmartEQ3 before it, and SmartEQ3 was the first approach to do things like this. We had a lot of features we implemented in SmartEQ4 in mind when implementing SmartEQ3, but we started implementing it as a usual plugin. At some point, we realized you don't just simply add inter-plugin communication at the end of the development cycle to your plugin to just some fancy feature enhancement. We really had to learn that if you want to do it right, you should design your entire plugin architecture with inter-plugin communication in mind from the ground up. And we really had to learn, and this is nothing new to software development, that abstraction is key, and especially when you saw the remote controlling of a plugin editor, vice versa. View processor separation plays a big role for us in our applications. So what we did, we said, okay, we have to write our own abstraction layer for this, and we called it SPAPI, Sonable Plugin API. So this is an internal layer we have built all our recent plugins up on. And when we get started back then, we just said, okay, let's focus on this communication channel between the view and the processor. Usually in a juiced-based plugin project, you can just grab a reference to the processor from the view and do whatever you want. We said, okay, let's start here and forbid that. We only want to pipe data through defined communication channels. And we started back with SmartCom 2, I think 2 years ago, 3, I'm not sure, which was a basic plugin with a single processor and a single view. And we just started to abstract this plugin from day one. And what we generally found usable was abstracting a plugin as a collection of somewhat connected entities, just a very basic abstraction. And for SmartEQ2, this was just a processor and a plugin editor. And the processor has a so-called main entity, the plugin editor has a view entity, and they are linked together by a main entity to view link, which is just a software abstraction until now. So we see we have two types of entities. The main entity is an entity that can somehow manage parameters, it can manage stateful resources. And the view entity is another kind of entity that has read and write access to the main entity's parameters, only read access to the main entity's resources, and links to it via this link class. And the link can furthermore be used to send directional requests, what we call actions. So we say, hey, plugin editor, do this, and this is just some kind of async message being sent over the link to the other end. And we define the concept of streams, which is what we basically use for metadata. So we will update a certain set of data every frame, and the view just should pick up this. And this worked out quite well and really helped us to define the first steps, but just abstracting this connection. We learned a lot, we refactored a lot. There were many versions involved to the state we are now. And once we got that up and running, we said, well, there should be multiple views for a single main entity. And again, we didn't start with a full interconnected swarm of plugins. We just say, well, let's add a generic developer view to our plugin. And this is what I want to show you here when I switch back to my session. Where is my mix? So when I open up this window, you see these two other windows opening up. This is something we do for our internal development builds, and you see this is a development build here. Let's just look at the parameters. So this is an entire list of all the parameters our plugin has, and yeah, I can just take one. Let's see zoom. This is quite yeah. So you see what happens here. We have now a completely different looking interface accessing the same set of parameters. Yeah. So we came up with a very good abstraction, and we actually use this a lot for development. So if the UI is not developed yet for a product, this is still a nice way to access DSP parameters while the UI is still being developed by another part of the team. So yeah, this was a nice proof of concept to us. And yeah, then we started with SmartEQ 4, which basically extended this to the level we are at now. So we have multiple editors, multiple views, and we can just cross-reference them. And we have a new link class introduced, which is the main entity to main entity link, which basically does all this computation of inter-plugin parameters and stuff. This is not strictly UI related. So this is our general approach for our framework. One particularly interesting thing is, so how technically do we get data from A to B? And we also abstracted that. So each entity in our framework can have multiple kind of endpoints, is what we call it. So here's a typical entity that has a memory-driven and a network-driven endpoint. Endpoints just implement different approaches on how to get data from A to B. And when establishing a link between two entities, we just look, okay, can we make up a memory endpoint link? If so, just pick this because this is the most efficient way. If not, pick the next best suitable one. And this also turned out to work really well. So these problems are solved. Next problem is service discovery. So how do entities even know about the existence of other entities? So until now, we haven't talked to each other, and we should make up some kind of connection. And the service discovery class is basically the answer to that. It will notify us when other entities enter our space and notify us when they disappear, and let us act on this. And the interesting question is, at which scope should this service discovery operate? So we just discover plugins within our process, on our machine, on the network. And we also learned that a stable service discovery is not super trivial to implement. And if you have attended Peter's talk, he went a bit more into detail on service discovery there. just as a quick information, we choose to do service discovery as a machine level scope using UDP messages broadcasted, and all the other instances will just listen to these messages and be notified if another instance pops up. And so last feature is group management. So as you see, I have seen in the small product demo, we have the concept of grouped entities, so a logical group of instances. And we took the decision that only main entities can be part of a group. There's no such big gain in grouping view entities for us. And the problem is all other entities must be informed about the existence of a group. So a group is a property somehow, between instances, but who is the bookkeeper of this information? And we had to learn that group management for our application was tightly coupled into the service discovery. So in the implementation, they really blend. And this is also where the most problems appear for us. So reliable storing and restoring of the group state in a plugin world is quite challenging. And so until now, you have seen what we have achieved with what we have available. But we could really do better with some host support. And I want to dig into that now. So first thing, as I mentioned, is service discovery. So this is a protobuf message of this beacon message that we send around from every instance every now and then to say, hey, we are still alive. You see, we have a certain identity we send some information about. So plugin wrapper types, process we run in, etc. And all the other instances can just keep book of these messages they receive and have an internal list of all the instances they know. And if at some point an instance disappears, they usually should send a bye message, and then everyone knows, oh, no, I'm gone. There might be scenarios where this does not happen. So in case a message has not been received for some time, we just consider it to have disappeared, which works. But it creates a ton of runtime overhead to find out information that the host already has. So why do we have to do this? Or couldn't we just ask the host? And that gets even trickier. So we somehow need to filter what we want to see in our service discovery. And a sensible filtering approach to us was then, after trying some approaches, filtering entities that are hosted by the same application or the same process. Because just imagine you have two different hosts open, both load a SmartEQ4. You don't want those instances to see each other, because there will be, why would you want to do this? This can just cause nasty stuff. So we ended up filtering by process ID. But this can fail in case we have a host that can open multiple documents at the same time. And there are hosts that can do this. So again, you have two sessions that are not related in any way to each other, but instances can see each other. And also the issue with sandbox plugins, which tend to become more more used approach in certain environments. Not that much on the DAWs we see in the wild. So there's this concept of maybe sandboxing the entire plugins in one process. This works for us. This is what, by the way, Logic does. But if all the individual instances are sandbox, we of course cannot filter by process ID. So plugins again will not find each other. Yeah, so this is a downside, and we would love to being able to just ask the host about which plugin instances do belong to my session. I don't care about anything else. Another point is that the service discovery can only find out that a certain entity exists. We have no context information. We can't find out about anything about the role the plugin has in the processing graph, for an example. So the user can group plugins in a way that are very, very stupid. So you don't want to, for an example, if you have a plugin chain and load up 2 instances of SmartEQ4, you can just put them in a group. This would be, there would not be any sense in this, but we can't stop the user doing stuff like this. And we would love to inform the user, hey, this might not be a good idea. And we even would like to find out a bit more of the context to make even smarter decisions about our processing. So if we know, oh, these are plugins on group buses, we might apply different rules or algorithms than if these are individual channels or whatnot. And we can think of, okay, something being scaled by a volume fader could also imply other algorithmic decisions for us than, just having the levels as they arrive at the plugin, etc. So what if there was an API to query that information about other plugins and at best the structure of the entire processing graph from within a plugin? This would be just so great for us. Next point is endpoints and links. So as I said, we filter by process ID at the moment because it's turned out to just be the stablest approach that we can come up with. So in our case, we only use basically in-memory-based endpoints. Even if we implemented the network-based endpoints, we ended up not using them because once you have filtered by process ID, there's no point in using a network connection to communicate with each other. This implementation just relies on a static map, which registers all the plugin instances, and then we can look up another instance by the ID and create a communication channel. Nothing too fancy there. But this has the boundary of the visibility of a certain static instance. So if we wanted to establish a communication channel between plugins of different type, so just let's imagine we wanted our compressor and our EQ to communicate because we see some good use case. This would not work with this approach because the instance of the equalizer and the instance of the compressor just has another static instance for this map, and they just don't see each other, even if they live in the same process. And this is not so easy to solve. We actually can't even group a VSD3 and an AU instance in hosts that support both, even if this would be not problematic at all. Don't know why you want to do that, but these plugin instances just don't see each other in our current approach, or cannot contact each other because they are relying on these static maps. So our wish would be, what if there was a just host-supplied data channel to send data from one plugin instance to another? We actually don't really care how the host would make this possible. We just would hand off some data, say, hey host, make us a link to there, send it over, send it through memories, through an inter-process pipe, through network, whatever. We don't care. Just ensure that this data arrives at the other end. This would be great for us and would really require reduce a lot of the workarounds we do. And last but not least, the most difficult topic is group management. So session persistent links and entity groups are a session-wide state. So if we created 3 groups in our session, this is more or less to the user a property of the session. But plugin formats only allow us to save in per plugin instance state. And this can become problematic. So be prepared for nasty edge cases when restoring a plugin state. So what we do is just store the group state in every plugin state. So what other option do we have? And now if we restore the whole session, one plugin state will be restored after the other. So the first plugin that comes up does not see all the other instances it has in its group. So we need to wait a bit if it will come up later and then try again. This kind of works, so this actually works quite well. It's quite a bit of overhead and a small phase where everything will try to connect to each other and try to find each other, and eventually this will lead to a stable state. It gets tricky if a plugin instance is copied by a user. So the state is just duplicated, and the state in this case contains the plugin's identity, and suddenly there are 2 plugins with the same identity. We can also work around by that by just checking if another plugin with that identity is already present in our system, trying to connect them. And if this connection succeeds, we know, oh, we shouldn't continue here. We were probably been copied by the user. But where it really gets tricky is what if there are DAW2U maintained plugin presets, and this is really a pain. So we got a support ticket. Group management goes crazy when a user applies a plugin preset in Reaper. And I just tried to debug it, had a test session, and yeah, until that point, I wasn't really aware that you can store plugin presets in Reaper. So what Reaper just does is doing a snapshot of the state and allowing the user to reapply that state. You can even say, oh, this plugin should always be constructed with that default state. And I think Reaper is only an example here. This is a feature that most hosts have. So now what happened is the user put a plugin into a group, applied some EQ setting and said, oh, this is a great preset for me, I'll store it, without knowing that they stored the entire group state with this preset. And then at some points, they apply this into a completely different session, and the plugin comes up with a group state that has nothing to do with the environment it's loaded in. And it constantly tries to find all the other instances it knows about, because this is what we implemented for the startup phase. So you just try and try again until all the instances you know that will be there, but they never appear. And yeah, I fixed it for Reaper, and I consider this to be the most ugly piece of code I ever committed to the Sonable code base. Oh, you really don't want to write this kind of code. So I really gave this into review and said, yes, this works, but I don't want to work it like this. This really feels so bad. Yeah, and disclaimer for other hosts, we did not find a clever solution like this. So this is a very specialized fix. In the end, we left it in there because it fixed a small problem for a small fraction of our user base. But yes, no, you don't want to write code like this. So what if hosts would either have built-in group management, so that we can just say, hey, host, we want now that we know plugin entities as a built-in host API feature, we want also a feature that's called plugin groups, and just store this plugin group along with the session. Or the other way would be that we can install some kind of centralized group management plugin instance into the host session that is only there once, kind of singleton. So let me draw a conclusion. We would at best yet to have another extension API that allows us to implement all this functionality without all those hacks. And at best, of course, this API would be as independent as possible of the individual plugin wrapper formats, because we support different hosts. But we would also be happy with vendor-specific extensions for certain formats to start with. So yeah, I did some thinking and thought, well, how could an inter-plugin communication API work and look like? And this is nothing fixed. This is more some thoughts which I would like to discuss with you later. And I have been working with ARA a bit lately. So I just tried out building stuff based on the ARA library. And I thought this is really a good example of a successful companion API that implements a feature that a specific product needs in a way that is, portable, extensible. And indeed, it partly implements some of the desired patterns that I mentioned. It has some kind of the abstraction for the host document. It abstracts what ARA needs to work, not the entire thing. There is this single management instance, which is a document controller in the ARA world, which somehow reminded me of the single group management instance that we wish for. And it even has the concept of separate renderer and view instances, which also somehow reminded me of what we did in terms of view processor separation. This is a really, really rough overview of some of the ARA model objects that exist. This is by no means an in-depth talk on ARA, but I was implementing a proof of concept ARA plugin, and ARA has this concept of, there are playback regions, basically this clips on your audio tracks, and the audio track itself is the region sequence, also modeled by a kind of a class, and it has those playback renderer instances, which are basically the processors that process on these playback regions, and this editor views, there can be multiple, there can be only one, and they can be used to view basically everything in this ARA world. It's up to the plugin to decide what they should view. And there's one single document controller. And I actually just put in our classes there. I made the region sequence a main entity. I made the view, the editor view a view entity, and I implemented our service discovery and the group management and the document controller. And all this started to work out quite nicely, and I was able to get, implement this pattern in ARA quite successfully. This was really nice. So I thought, this could be really a good approach in some ways. But does ARA already solve the problem? I don't think so. It solves the problem for a very specialized use case where you want to access audio data that is on your file system. That there's no solution for generic plugin use cases. So the ARA graph stops after this first playback renderer instance that is used to transform audio files into an audio buffer in some way. And there's no abstraction of the rendering graph contained in the ARA document abstraction. But still, this is now a shortcoming of ARA. This is just not the scope of ARA. And still, it is a very, very good example of how an extension API can be approached. So I really read the code a lot in the meantime, and I was really fascinated about, this is how you can approach something like this in a good way. So how can an IPC API that I have in mind work and look like? So we would need multiple entity classes. I presented the view entity, so just more views to some entities that are used for user interaction kind of stuff. So basically UI entities. Main entities, so plugin processors, the document controller, everything that has some kind of stateful functionality and is available for connection. And for a generalized model, I would also introduce kind of passive entities that could model everything that is there in our processing graph that is not available for connection. So probably all the plugins currently out there, my volume fader in the processing graph, latency compensation inserted somewhere. So yeah, this could all be modeled as passive entities that can be found on the processing graph but are not available for connection. You can maybe query some information from them and that's it. And I think of having something like get IPC handle, so a function that can be called from within your plugin processor, and if by some means there has been a handle injected via a format extension, then this will be non-null, and you can do stuff with it. You can just say, hey, so let's give me your service discovery instance. And hey, service discovery, me as a plugin instance, I want to be notified whenever a main entity from Sonable SmartEQ4 comes up. And then the host will say, okay, my service discovery will manage this for you. This would be great. So this only sketches a very simple use cases, does not model querying the entire processing graph. So this would be probably a lot more complex. Links. So I thought about links. How should that work like? And I think one option would be just to define links as a channel for binary blobs. So you can say, hey, on my entity, I set a data handler function that just receives a few bytes now and then. This can be some async call. We get an information on what the source of the data is, so which entity sent us this data, and then do whatever implementation specific you want to do in your plugin. And the entity can connect to another entity, and if it can establish a link, then it can use this link to send raw data to this other plugin, which leaves the communication protocol totally up to the plugin, which can be fine because maybe this would all be all we need to make sonable inter-plugin communication work. Another option would be to define a more fine-grained set of things you can do on a link, and this actually resembles our SPAPI code quite a lot. So this mainly a copy-paste of code that can be found in our code base. So we do define these things, actions, resources, parameters, and every link, depending on the scope and depending on the access rights, you can just access the resources, the parameters on the other end, request them, set them, send actions, send stream updates, etc. This would allow for a much more clear defined set of operations you can do between plugins, but would also require us to agree upon a certain standard of what kind of stuff you should send over a link, how you should represent this. So I'm not decided yet which approach would be the best and would be most likely to ever be implemented by hosts out there. And same goes for group management. So there are also multiple different approaches that could work. I mentioned the ARA document controller approach. So we could say, okay, our plugin defines a group management instance entry point in its binary. The host could just see, okay, does this plugin also have a group management plugin in the binary? If so, instantiate this once and let it do its job for this specific plugin. We could even define a new kind of plugin type that can be placed into a certain folder on the machine, and the host could just say, oh, do I have group management plugins? And could ask these plugins, so tell me which group of plugins can you manage? And then this group management plugin says, so I'm the one responsible for managing groups between SmartEQ4 and SmartCom2. And then the host says, okay, fine, I'll supply this information to instances of both types. Could become quite difficult to maintain and quite complex. Not sure if this is the best approach. And the one that I maybe like the most is that this API just defines a set of how to create groups. So you can just ask the host for, okay, can you please create me a group, maintain this group, restore this group. No matter how you do this, you have to do this. And then the host cares about serializing the state of this group, restoring it, making sure that when entities come up again after restoring a session, they have been assigned the very same identity as before. So, yeah, these are options. And I think the question here is how sophisticated should groups be? And stuff like inter-group computations, where should they happen? So you see this group impact I said. This is a computation done for all plugin instances on data gathered in the group, but that has to be performed in one specific place. We go approach it by electing a group leader plugin at the moment. So this group leader will then have the job to compute this inter-plugin curve and distribute it back to every other instance. But yeah, this could be done different. And if there was a central group management instance, this could also do vendor-specific computations that rely on multiple plugin instances. And it also is up to the question, should we be able to group plugins of different types or even different vendors? Or is this only a vendor-specific requirement to group their plugins? And yeah, I'd really like to ask you as the audience, how can we settle on a standard on questions like this? So we as a plugin developer have a lot of requests, especially towards the host developer community. I don't know where and how to discuss this best. And I don't know how we could settle on a standard. But yeah, I would really love to open up this discussion now. So yeah, let's discuss.